Hi, Greg Whitlow, H2Power. I'm the CEO and founder of H2Power, and I'm partnering with H2E Power Systems out of New York, India, and Germany. We're demonstrating their 1.5 kilowatt Hexas SOFC fuel cell. It's been running on and off for about 12 months. We produced 13,000 kilowatt hours here in Lucas County, Ohio. Now I want to kind of talk to you about the system. The system is pretty straightforward. This is the fuel cell itself. This contains the chemical reaction that is taking the hydrogen that's produced from the natural gas and converting it to power and heat. That heat is generated here. It's a closed loop system, so we got water going out at roughly 135 degrees and coming back at roughly 105 degrees. You'll see our next hookup is our gas system. It's connected right into our infrastructure here in this building. And right now, the gas is approximately 15 millibars. We need it a little higher in the 30 range. But it is producing power for us as we speak. And lastly, we have our electrical hookup. It's simply a three-prong wire that we connect to our grid. And so you can see here, it's just on a disconnect shut off here that we put this together. But as you can see, we're producing power as we speak using natural gas as the fuel. Let's talk about how the appliance comes together here. So from an electrical perspective, we got 3 wires coming out of the system. This is a ground wire, and these are the 2 power wires that connect into our 230 volts when we produce energy, pushing it back out of the system. And then we got the 3 connections. We got 2 water connections and a gas connection. These are simply, we've got this set up for this system we're staging. We want to keep track of the heat and pressure coming out of there, but we also added the water or the air release valves here. And you can see these are systems that we're ready to connect and put that together for this appliance. And again, the gas line is just a simple appliance connection into the main gas line into our system. So here we're at our indirect, this is a 30-gallon indirect water heater. And what that's doing is it's bringing the hot water produced from the fuel cell. That water is coming in here at a closed loop system and going back into the fuel cell. But we're extracting the energy from that with this secondary system here. You can see I have a pump on the floor that's pushing it in anywhere from 1 gallon to 2 gallons per minute. And that is pushing that water to use in radiators that are heating an office and a bathroom. So the system is operated off software that we have on a desktop here in our lab, and it manages the gas input and the output, which you see at the screen on here. So we can modulate the system to run at 30% up to 100% wherever we need it to be. And with that, we have some fun facts for the system. Right now, we can create 1 cubic feet of natural gas produces just about 9.66 a kilowatt. And then right now, our cost to produce 1 kilowatt of power is 8 cents a kilowatt hour, as well as we have inventory in the US.